I think most people by now have started to realise that there's something fundamentally wrong with our current social economic system. Unlike bacteria in a petri dish, our exponential growth will eventually stagnate and go into collapse. Now, there are various people who put forward various tweaks to our current system, but I would argue that that will just delay the inevitable. If we don't get to the core problem of this exponential growth, the system will go into a state of stagnation and collapse. If we accept that our current system will do that, then the question then becomes, what type of socio-economic system can we have that is sustainable? That's where the design comes in. That's our proposal for a sustainable socio-economic system. Have a look at this. This is a computer motherboard. This is quite a complicated piece of equipment. It takes many years for someone to understand this, to be able to design one of those and to make competent decisions. Most people who use computers don't really understand how they actually work. And it doesn't matter as long as they do. But there are many aspects of society that are technically complicated, from transport systems to medical health care systems to information systems, farming, manufacturing. All these take many, many years before somebody can actually make a technically competent decision. And most people do not actually understand what goes on around them in society. As long as it all works, nobody really cares. But this is our first observation for society, that it has this complicated technical side to it, but it also has this people side to it. The people side deals with social interactions, ethics, morals, the things that everyday people do on their everyday lives. And then we have the technical side on the other side. I make this distinction, but it's also important to remember that the people who work within this technical side are also the same people who live in the people side as well. But we propose a system that it makes this sort of split, and we propose a system where the technical aspects of society are actually managed by those people who are trained and are competent to make the decisions in it. So medical doctors, nurses will make decisions and policies regarding medical care. Manufacturing engineers will make decisions regarding manufacturing. Power systems engineers, transport systems, whatever, or made decisions in those areas are made by people who are technically competent about those. But we also recognise there's a lot about society that doesn't have a technically correct solution. Those things belong on the people side. And we propose a system where people make the decisions affecting their own lives locally on their own communities in what we propose for a direct democracy, the use of direct democracy to do that sort of thing. So the other fundamental foundation for the design is really the application of science to society. By science we mean both a method for knowing and understanding how nature works and a body of knowledge that has been built up for the application of that method. If you look all around us, science offers the most comprehensive, best understanding of nature that we have, better than any other system of knowing that we have. It's produced far more successes than any other system of knowing. So that's the fundamental roots of our system. We know and understand nature through the use of science, and then we apply that knowledge back to society. One thing that we learn from nature is nature doesn't have a centralized hierarchical form of governance like it's a military command or something. It's a very distributed form of control within nature. Nature is composed of many different types of organisms, from trees to mammals to insects, whatever. They all interact at various different levels, largely in a cooperative system. Some competition, but largely cooperative in various different levels. So that type of system is what we want to emulate how nature actually works to produce a system that is balanced, balances our needs with those of nature, and therefore has a sustainable core to it. Such a system like that is called holonic. It's a technical word for it. Holon is part whole. An entity itself is part of something, but it's also an entity in its own right. So a tree you can study as a tree by itself, but it's also part of a forest. So we want to build up communities that are communities in their own right, but they're also part of networks of communities, and those network of communities are part of other other networks at higher levels. Layers within layers within layers, and the same reflects on the technical side. This brings a system where power is distributed, there's no central authority, Power is distributed among the people at various different levels and at various different expertise. And also, power becomes very localized, so people are making decisions that are local, that are affecting them on a local level. Then, within this system, the technical side effectively becomes like a skeletal framework where the communities interact with them on as much or as little as they would like. So the communities have their own characteristics, their own way of doing things. So you could have, for example, primitive communities. You could have transhumanist communities that make a great deal of demands on the system. You could have religious communities, atheist communities. There has to be some sort of common basis to them. They have to tolerate each other. Don't have to like each other, but they have to tolerate each other, to cooperate and work with them. There has to be a sort of common basic level of human rights, and people have to have the right to be able to move from one community to another. So as long as we've got that common baseline, the communities run themselves, and they run their own networks themselves, say on a direct democracy application, with the technical things being managed by technical experts. The design also purports a moneyless system, so we don't use money in this. It gets away from this exponential growth problem. Instead, we have a resource allocation system that we call energy accountancy. Energy accountancy works on the what we know about nature, that everything runs on energy. You can't do anything without some degree of energy. So society has a certain amount of energy available to it, and if we extend that a bit and just concentrate on the usable energy, we have a concept which we call exergy. Exergy is usable energy. And it just so happens that we use exergy, it also gives us a way to measure materials and information. So exergy gives us a common accountancy unit that we can use to measure how much materials and how much energy we have in society. We can then divide that up to the people, so that people can then decide how it gets allocated, how this energy gets allocated within society. We call those allocation energy credits. Energy credits are not money. Energy credits is a representation of the production capacity of the society in energy terms. And the people decide how that production capacity gets allocated, what gets produced. Back behind the system, we have this management of experts who are managing the system to manage it in a sustainable way, to manage it in a balanced way. We're balanced with nature to keep the system going in a sustainable way. For this type of distributed system to work, it has to have, everybody needs to be working towards goals that are compatible with each other to an overall goal. The overall goal we have here is the highest standard of living for the longest time possible. The highest standard of living to us means it's going to be a technological society. Longest time living, as longest time possible, means it's got to be a sustainable system. So it has sustainability built right in the core. It's a sustainable, dynamic system. There's probably much more I could go on about the design, but it's all in the book there if you want to read that. But I think that summarizes probably the most important points. Yep.